Hi, good afternoon, everyone. On behalf of PTC and ET Auto, we would like to thank you for joining us today. It's a lovely day today here, at least in Bangalore. The session we are going to be talking to you about today is how to unleash the value of product data with next generation PLM. Um, we have come a long way since the discovery of the wheel. With the advent of the fourth industrial revolution, the automotive industry is really going through a paradigm shift right now. And more so than ever, a robust and smart connected PLM system is very, very crucial for all industries now, especially the automotive industry. So your digital transformation journey will begin with a brief introduction about PLM and how it's changed across the decade, the centuries, and over the years. This session will be moderated by Mr. Dhirendra Kulkarni, who is the Technical Sales Director at PTC India. Followed by this, Mr. Ravi Chandran, the General Manager of Corporate Research and Engineering at Kirloskar Oil Engines, has very kindly taken his precious time out to help us and take everyone who has participated in this particular session his experience of deploying a PLM system. It's very complicated, and I'm sure he will be able to help you guide you through the process firsthand. Before we start with the formal presentations, just a quick feedback. If there are any queries or doubts you have, there is a question section on the right side of your page. Feel free to type out anything, and we'll try and ensure that we answer all your questions. So, without further ado, Mr. Dhirendra Kulkarni will take you on this transformational journey today. Once again, thank you for joining.
Hello, can you? Hello.
Hi.
Hello, can you hear us?
Yeah, I can. Please continue.
Okay, great. So, good afternoon, Kalani. I'm sorry we were not able to hear you properly. So, I think you have already given an introduction, right?
Apologies for the internet connection, everybody. Sorry.
Okay. So, okay, let me start. My name is Dhirendra Kulkarni. I'm a technical sales director here at PTC. I have an overall around 20 plus years of experience, last 13, 14 years in PTC, especially in the area of product lifecycle management, digital transformation, and things like that. So today I'll take you through the webinar on how do we really unleash the value of product data with the next generation kind of a PLM. And we are fortunate to have Mr. Ravi Chandran, who heads the PLM program at Kirloskar Oil Engines here in Pune as the guest speaker in this webinar. He will be sharing their experience of implementing PLM, how they went through a transformation journey using the PLM. So he will be sharing his experience and the case study from the COEL side. With that, we'll just start the webinar. So I would like to first start with providing setting the context with providing the definition of PLM and also what's really happening in the world with respect to the PLM. So many of you who have joined already know that the PLM is all about managing the entire product information. By definition, per se, it is managing the entire product information throughout the life cycle. At all stages of the product development, right from concept, right to design and development, to manufacturing, service, and even when the product gets matured into the field, right? The all absence of all aspects of the product lifecycle management, managing all the information, enabling a single source of truth across the organization, so that there is no second question about the source or the integrity of that particular information. So whatever information comes from the PLM is authorized and latest, and that's the single source of truth. So as in this particular process, PLM basically provides three things. I will also start my pointer here. So basically, it provides you the three important aspects of the product lifecycle management. One is the integrity of the data itself, maintaining the single source of truth. PLM also optimizes the various processes, as we just discussed about the various lifecycle stages and all the processes under each those stages the process optimization, increasing the efficiency and effectiveness of those processes. And most importantly, PLM provides a collaborative platform because in today's distributed product development environment, with multiple design centers and multiple factories and multiple collaborations with different companies and things like that. So basically PLM provides a collaborative development platform where all the stakeholders involved in the product development can collaborate and concurrently develop the products in a more efficient and effective way. So that is on the left hand side is basically the definition. And if you see a short picture here, it covers all aspects of the product life cycle, right from requirements, managing the portfolios, all the aspects of the design, then getting into the manufacturing, the simulation, then the actual manufacturing, the testing part of it, then actually distributing that, and also when the product is in service, maintenance and maintenance of that particular products while it is in operations, and repair and other things until the disposal of that particular product. So that is precisely what the entire product lifecycle management covers. But the truth is, on the right hand side, predominantly PLM is considered to be more like an engineering software, or probably it is mostly used in the engineering department only, right? Whether you talk about the CAD data models and the 2D drawings and 3D drawings and things like that, the document and all are managed, but not the other aspects of the product development. For example, in this picture, if you see whether it's an engineering BOM, which is predominantly managed in Excel, right, and shared through Excel to the ERP systems or the downstream functions, the multiple configurations of the engineering BOM itself, where the different versions of those or different configurations of those things. Then when it comes to manufacturing, the manufacturing creates their own information from manufacturing perspective, whether it's a manufacturing BOM or the resources like tools, jigs, fixtures, or it can be work instructions to the shop floor operator and things like that. So these information is predominantly managed into ERP systems, whether it's SAP or Oracle. Different people use different ERP systems, and again Excel and Microsoft Word playing a major role in managing this information. Then thirdly, when it goes to the services side, again the service aspects, whether it's the illustrated parts catalog, illustrations, service manuals, repair manuals, again these are managed independently and not really reusing the engineering information that is created, but taking all together and converting into different formats and putting them together and then creating the PDF out of it again. And also when the product is in the field, when the product failures or customer complaints comes, they are again captured into different systems, whether it's a root cause analysis or a corrective and preventive actions are taken on the top of it, are again all done in an isolation, and sometimes those information are passed on back to the engineering through these particular emails, right? So precisely, if you see the definition, the PLM, where it is supposed to cover all aspects of the product development, but what's happening really is mostly used in an engineering, right? The rest of the information in the other areas is disconnected from the engineering and mostly managed in multiple different systems, including the file server and Excels and things like that. So what it really does is, it basically, digital continuity is lost because all this information is seen in silos. There is no connectivity. The traceability is lost. For example, when you create a manufacturing information, which is supposed to be created from engineering, though engineering information is referred, but it is not connected, right? So tomorrow when the changes are going to happen on the engineering side, we get lost the traceability, what is the upstream change and what is the downstream change, things like that, okay? These changes are done in silos. So if you see the what's happening here is, whether it's engineering, manufacturing, service, whatever, it's all about data, right? It's all about capturing the data, associating the data, establishing traceability of the data, and also making sense of the data with certain analytics to understand and to take some informed decisions, okay? So this is all about data, whether it's a product data, it's a project data, or it's a data related with the communication, whether it's an internal or external and things like that, right? So in the previous slide, what I showed, definition of the PLM versus what is exactly is happening. If you see that digital traceability is lost, but if you see here in this particular slide, this is how it is supposed to be established, right? The information coming from sales by capturing the voice of customer, to the engineering, to the supply chain, and then to the production quality, and then coming back to the engineering. So that digital thread has to be established. But really, how do we do it, right? And data is a new while now, because everything is dependent about data. A lot of decisions are made based on the analytics of the data. But if there is no proper digital continuity between these, or the digital thread is not maintained, and if you see the data isolation to some agents or wrongdoing things on that. So can really PLM enable this entire digital thread? Can PLM really has evolved to to the first extent, whether it is really to the extent of enabling the digital transformation by connecting the entire digital thread right from concept to the maturity, right? So that we will see in the another very important aspect is how this physical and digital worlds are totally different. Digital world is all we talked about, the data that we create in engineering, manufacturing, service, and things like that, and physical actual objects are in the field. Now CAD is provides the data from digital world. Now that data is taken back to the physical world, to the IoT, right? To the Internet of Things is is the new concept of connecting the physical and digital world by sensors, getting the getting the data from those sensors through the connectivity back to the digital world, and IoT is that. And once we have the data back, we can through the augmented reality, which is basically imposing the digital data on the physical product. Through that data we can take the digital data back into the physical world. So basically if you see this P, which stands for physical, and D, which stands for digital, this physical and digital convergence basically enables to really understand the physical product, how they're behaving, and able to take the data, balance that data, and make some improvement on the product with respect to cost, quality, etc. So essentially IoT, which is enabling this physical digital convergence, is what is precisely is equal to PLM, or you can say that IoT actually completes the PLM, because PLM is we more talk from a digital world, but now with IoT physical digital convergence can happen, and IoT really completing that augmented reality altogether basically connects this physical and digital world, and unlocking the tremendous potential that we can unlock the value with this physical and digital convergence. Okay, just before I hand it over to our guest speaker, I want to show some kind of a complete connected landscape, or a complete digital landscape, how PLM really enables that physical digital convergence and enables that complete digital thread, right? Now if you see in the digital world and the physical world, these are different stages of the product development, and this is where once the product is in the field. Okay, now this particular animation tells you that under different stages of the product life cycle, the information is captured. For example, voice of customer, that how the product should be designed. Based on capturing the voice of customer, we do a 3D CAD model, and through that CAD we actually derive the complete engineering bill of materials. Then that drives the manufacturing bill of materials, and that drives the service bill of materials. Okay, so this is more from engineering perspective, this is more from manufacturing perspective, this is more from service perspective, which we will hear more from Mr. Ravichandran on what is the importance of these different BOMs and why company needs different BOMs. Those things we will hear again. And then finally the manufacturing BOM is published into a ERP system for further transaction. And at the same time here, the data is also given to the factory for the production purpose, where the production will start, and also to monitor the machine's health and keep the uptime of the machines. They're also connected with sensors, and that data also, like for example OE of an equipment in terms of quality, performance, availability, whether the machines are operating or not, whether the data is transferring from PLCs and OPC servers of the machine back to the PLM. So those kind of controls we can observe it here. So this is how the data can be transferring here. And once it is manufactured, the product is in the field. For example, this is more of a solar panels here. Okay, now this solar panels will have certain sensors, and from those sensors the data can be basically if required to simulate based on the real-time data, because earlier we would have simulated based on historic data, but now here we will be simulating more on a real-time data, and take that proper corrective actions to make it more robust and more realistic. So that is how the data can come back. And similarly, the CAD data, we can create some digital experiences in terms of augmented reality here, and which can be used further for servicing the particular product or doing the maintenance of that particular product, right? So this is how this physical digital convergence can be established, and this is a complete connected digital landscape that PLM can really enable. Okay, and the center part of it is the IoT platform, which provides all the required data coming from the physical world. Right. So here there are more examples. Solar panel was just one example. It can be bike, it can be a car, it can be some other missile systems and things like that. Right. So that's the context that I wanted to set up. Now I will hand it over to Mr. Ravichandran, who heads the PLM program at COEL, to share their experience, their transformation journey, and how they are adopting or how they have implemented and adopting this PLM to the newly evolved PLM, which is not just engineering but across the organization. Yes, over to you, sir.
Thank you, Dhirendra. Yeah, hi viewers. Thank you, Dhirendra, for the good introduction and for having also introduced and made my job easier for having explained what PLM is. What I would do here is go step by step in identifying the specific areas of how a company needs to identify its needs on the PLM and how it would like to go forward for the implementation, right? So just put off my webcam. Okay. Right. So in this slide, you see an arrow which a particular slide which already was shown by Dhirendra to you in his earlier statements, which covers the PLM in different domains of the business, right? So at the top end of the corner, you see requirements, which is generated from the market, where marketing holds on to the requirements, what is the requirement, and pushes it into the organization, whether it can service those requirements. You have your products, which are having its own portfolio. You need to plan out a product portfolio. PLM can be used for those reasons also. Sometimes we need to have a conceptual design to be made before we can finalize on a particular product. This itself can be managed in PLM environment. We have product engineering and manufacturing engineering. Now both these are two separate domains and have their own specific requirements by themselves. In the product engineering, you will need to do FE analysis, maybe flow analysis, maybe some other simulations that require to be done before we can finalize on the features of the product, before we can finalize on the strength and the robustness of the product before it goes into the market. Similarly, when the product is given to manufacturing, it is required to see how this particular product can be managed, manufactured, and effectively having a good EBITDA and sell it to the market. Right? So manufacturing engineering has a big role to play in PLM by itself, which was earlier only the domain of SAP or ERPs. There are builds, first protos that is made, which is also maintained in PLM. You have test data that can be maintained in PLM and pulled on as required. We also have sales and distribution, which can have its own database. Today, there are many other softwares available which works with ERP in CRM to work on this, but there could be some specific areas which can be maintained as a database for sales and distribution. In services, another core area, niche area that the PLM has now expanded its domain, and you have good products servicing this particular in-service area, and maintenance and repair, of course, up to disposability, right? So when we see here, PLM is managing the complete product information at all stages of product life cycle, from concept to. What drives a company to adopt PLM? People look upon PLM as, on the right side, you can see there are two tables. One is talking about business objectives. The other is talking about the operational objectives. Many people have trouble in various areas. So sometimes businesses say that, okay, I want to improve my product development efficiency, or improve the time to market of a new product, improve product quality, or increase product innovation. Okay, the ones on the left side are some, I think this was done by PTC, where about 500 customers had participated in a survey, and they found that the business objectives, driving factors were as it's seen here. In operational objectives, also you have certain areas that a company would like to consolidate its IT systems or redistribute across global teams, etc. When Coel implemented PLM, right, we thought about the following objectives. The infrastructure and platform needs need to be aligned to growth requirements, both organic or inorganic. We need to be responsive to market needs. We need to have a lower time to market. First time right product introduction, integrated new product development approach, knowledge management and reusability, and sustainability and evolution inbuilt in PLM ecosystem. So these were our guiding factors when we implemented PLM. This is an example, but this is what we chose to have a top drive of PLM implementation. Begin with, we started with a mission, enabling PLM for transformation of product engineering processes. So since the product is given birth in engineering, we concentrated on having the design repository and the processes involved in design to be first focused upon. And thereon, we have now moved towards a vision enabling PLM for business transformation. In order to choose the wide dispersed product portfolios available within PLM, we made a ready reckoner. The lower strata is the foundation phases. All those integrated part processes, BOM processes, EBOM processes, MBOM processes, change management, CAD, design repository were all a part of our foundation phases, which we implemented first. Okay, based on the robustness of implementation, we put on the next strata, that is efficiency and effectiveness phases, in which there were deep dive processes which relates to purchase, which relates to validation, which relates to options and variants, e-parts catalog, so on and so forth. Both these phases develop their own reports on a daily basis, weekly basis, 6-monthly basis, quarterly basis, or yearly basis, which feeds the strategy to further refine our deployment strategy. This diagram shows you the integrated nature of data in PLM. So when Coel has implemented part data, so all the part data is in sync with our ERP, right? So there's no delta between PLM and ERP as far as the part and part information is concerned. So every information related to the part in terms of design is available in this particular phase. CAD is an integral part of the parts data, which is again tightly dovetailed into our systems. We have EBOM, which I will explain later, MBOM, servicing BOM, marketing bill of material, and design data, all very closely dovetailed with an engineering change management in place, which caters to manufacturing, servicing, end to end. This is about the data in PLM. Now we talk about the nature of processes in PLM. We have part processes. Earlier in ERP, we could create a part in a matter of minutes. Today, a part, if it has to be created, it requires to serve a long list of checkpoints, whether I have an alternative in place. Why do I need to create this part? Whether this part can be used across the complete platform of the projects, right? Whether I can reuse this part elsewhere, etc., etc. It also gives me similar parts which can lower my time to design, and therefore the part processes builds all this into place. So instead of creating a part in a minute and forgetting about it on the parts lying unused, we have a process which takes care of the birth of the part to disposition of a proto part. Similarly, a bill of material is built in a similar way, which will cater to the different demands of engineering, the way it is creating a bill of material based on the CAD outputs, how the manufacturing will create their manufacturing processes based on a bill of material. So therefore, they need to realign the bill of material as per their processes, and also to servicing, so on and so forth. Design processes, we talked about some of the design processes and parts. There could be other part of design processes could be a DFM process, design review, DFMEA, FMEA, or DFX for that matter. Whether I want to do a design for serviceability, I want to do a design assessment for aesthetics, or any other reason. So you can have all the design processes inbuilt and integrated along with the part and bound processes. Right? This is a DFM process where in concurrent design, we also collaborate with the manufacturing functions of manufacturing as well as sourcing to give their inputs for a new design to come up. A non-conforming product is also handled in PLM environment and its processes. These are deep down process of purchase kits and validation kits. This is a small snapshot of what a bill of material looks like for different domains. The requirements are captured in a non-intrusive way without any part numbers. So these are requirements. From requirements, it can get transformed on to either an engineering bill of material or a marketing bill of material. If it's a standard configuration where marketing just needs to pick up certain features and puts them together, they can directly make a marketing bill of material and send it for manufacturing. If certain elements require engineering to be done, you make an engineering bill of material, which is as designed, right? So there could be 90% of the aspects which are standard, which has come from marketing bill of material, and the rest of the 20% may be engineered, and you make the protos for that, align it, and release the bill of material to manufacturing, who then redo it in the way a manufacturing process can optimize for the value to the company in terms of manufacturability, in terms of the lowest cost of manufacturing. Then in that, once it is manufactured and the product has gone into the field, it is imperative that this product be serviced in a proper way. And in order to service effectively, an EBOM could be converted to a service bill of material, and various kits can be made to optimize your service offerings to a customer, and that is service bill of material. When this concept was first introduced to us, I myself had a question as to really do we require so many bill of material? Why don't we work with a single bill of material, right? But now 3 years since we have implemented the EBOM and MBOM concept, we have moved forward to a marketing BOM and a service BOM, and have proved that there's quite a lot of interdependence reduction by having the functions work in their own BOM areas to the best optimization for their own work areas. So what is achieved so far as COIL is concerned are the part creation processes. The CAD is tightly integrated with the PLM environment so that we have a very good reusability as far as design data is concerned. The EBOM change management is firmly in place. MBOM and its change management is firmly in place to reflect upon the changes in a manufacturing environment with a tight integration with our ERP, which happens to be Oracle here. We also have put into place the service bill of material, and that is also going into ERP for servicing purposes. Now we have leveraged the CAD data to create the e-parts catalog, and we have a web-based e-parts catalog available to all our dealers across the country and across various other nations that we service. Going forward, we are in the process of implementing quality solutions, business reporting, options and variants, and few other modules. This is just an example of how we can leverage what is designed by engineering for the purposes of other functions. Let's take manufacturing for example. This particular 3D, which was designed by engineering, is available as a visualization, as a lightweight model for a manufacturing organization or a quality organization to better produce their documentation and process sheets. It can also be used for other functions when there's a failure, annotate it, mark it, so that much less time is involved in pulling up the drawings for that and really coming to the root cause. So an engineer or a servicing guy can very easily say that, yes, I had a problem in this particular area, please help us solve this problem. Engineering is able to identify those parts relevant, pull up those drawings, do a design review for that particular purpose. So this is how whatever data is there in engineering can be leveraged by downstream departments to better service their needs. we have certain softwares which is integrated with PLM and the design softwares in order to download the design data and just explode it in a click of a button, right? So you create these explosions within 5 minutes without touching the basic design data that's available in PLM safely. We can annotate it, put it into a parts catalog, or create 2D illustrations with it. The same data can be used for a spare parts catalog, unlike the yesteryears where you would draw them in AutoCAD or do them with the specific tools. Now you do not need them. The same CAD data which is there by engineering can be used by downstream departments without fear of corrupting the original data which is available with engineering. So this is the power of integration across various functions which has been brought to PLM. Okay. Okay, this was just an animation which showed that we can use the animation also for explaining how the design is data can be leveraged by service personnel for training their personnel or training their dealers across geography and across various other portfolios.
How same things can be incorporated into parts catalog.
Yeah, the same can also be incorporated in the electronics parts catalog. So we don't have just a visual of a 3D, but an active representation of a 3D which can be animated in a matter of minutes. These are some of the pointers for an effective PLM implementation. Just automating an existing process through PLM implementation may break or make the end objectives of implementation. It is vital to holistically visualize the end-to-end solution and look at PLM implementation as an opportunity to revisit the existing processes objectively and transform the way you work, which should be towards greater effectiveness and efficiency. Implementation needs to be done in small steps. Only after having a visualized end-to-end implementation possibility firmly set in your minds. Adhere to set of organizations' values to design and implement the processes. It has to be a top management drive for an effective adoption. Once implemented, processes, tools, and utilities need to be continuously evolved to greater efficiencies and effectiveness. So with this, some of the pointers on effective PLM implementation, I hand it back to the organizers for any. No, I think Dhiru would like to continue.
Yeah, no, I think we'll take the question answers, and then we can come back to this. Yeah, hello, Kalyani. Hello.
Hi. Yeah.
Yeah, are there any questions?
As I had mentioned before, if there are any questions, there is a little box on the right side of all the attendees. It says questions. Feel free to type out any queries or doubts you have.
We cannot make it bigger, or okay. Anyway, I think there is one question which I will read out to you, sir. How can we make the optimal use of big data in pre-design phase? What is the latest technology trend in managing the PLM? with evolution of new technology, product life cycle have been reduced. How auto companies can collaborate with software companies to develop better products for future. Kalyan, we are not able to really read these questions properly here. It's a very small window. If you can read out the questions, we'll be able to answer it.
Yeah, I'll just get access. You can start answering the first question about big data.
Fine. So we would answer it in two parts. First of it will be handled by me on the PLM implementations, and what is the emerging technology will be answered by Dhirendra.
Yeah.
As far as PLM is concerned, if you looked at the presentation that we gave, it was an end-to-end PLM, which we talked about right from the market requirement gathering up to servicing of the product and it reaching the customer. You're able to manage all the data that is related to that in the form of knowledge. Okay. Now this can go a long way into redefining our products, into getting additional requirements into our products, getting greater efficiency on the products, and also on the processes to have a better EBITDA coming out of it, having a better, lower cost of manufacturing coming out of it. This is one aspect of it. Second aspect, when you take an end-to-end PLM implementation into mind, you can also box in areas where you have connected products and connected processes, right? Now, we are thinking about a connected plant wherein all our manufacturing that happens in our plant can also have machine-wise, like Dhirendra showed in his presentation, OE data coming in, and there could be some specific areas data is getting to PLM and it's useful for analysis. So that is one way of doing it. The second, which we have been doing for years together with our engineers, have been monitoring the field and getting the data to a single point using analytics tools and coming out with an analysis of how we can predict how a product will perform. So this phase was discrete earlier. It was independent in silos. Today you have an opportunity to have it integrated with PLM. So with this, I will have Dhiru answer the next part of big data.
Yeah, I think you have already answered it, but just to add to that is basically how do we make optimal use of big data in pre-design phases? For that, we need to have your product smart and connected. The moment the products are smart and connected, the moment we start getting the data from the field, okay, to a particular IoT platform today, for example, PTC's ThingWorks, then that data is internally integrated with CAD and PLM systems. When I say PLM, I consider CAD as part of the PLM because there is a CAD already, data is already managed inside a PLM. So this real-time data of the product, how it is performing under different climatic conditions, can be put back into the CAD designs through this IoT platform. And you can actually do, like Ravi said, do the analysis based on the real-time data and really find out, how the designs are, whether you have over-designed or whether you are under-designed, because we always do the design and analysis based on historic data and based on some past performance and things like that. But now today, since we have this data back with the PLM platform through the IoT platform, we really have a great insights, and we can really do the analysis based on that real-time data, and which is really help us to either improve the design, improve the cost, improve the quality, and things like that. That is how this data can be made or be used into the pre-design phase by doing this physical and digital convergence that we just spoke in the beginning. Okay.
We have a
Any other
very
questions?
interesting question next. If the dependency upon the different verticals, sorry?
Yeah, please go ahead.
Yeah, so this question is quite interesting. If the dependency upon the different verticals, engineering, marketing, sales, etc., merged with each other up to a certain extent, as per what Mr. Ravichandran had said, then there is a consequences up to certain limit. So they want a justification on this statement that was just made.
Okay. Very interesting. This is called breaking the barriers. Okay. At the same time, optimizing. Uh, we had a situation which is more likely to be in most of the companies, like you have departments acting in silos. and interdependency of departments. Okay, like manufacturing would always be behind engineering to change the bill of material to the ways they want to manufacture, and if there's a single bill of material. Okay, but engineering would find that not in their priority list, and therefore manufacturing would keep on waiting, but engineering would do it based on its own priorities. When engineering wants certain things done in a particular way, manufacturing may not have that as a priority altogether. So the best way is to empower each department to work its own areas or its own competencies to be leveraged. Therefore, we need to reduce that interdependence extremely to low phases. And that's how, when you implement PLM on different domains, certain domains require only one small tick mark from some other domain so that they are able to give their valuable feedback. When that is done, this particular department is able to leverage that particular information and do their work more holistically. I can give you one example of sourcing and engineering. When engineering makes a design, it would like to show this design to sourcing, whether they have got some comments. In a traditional way, it would go by post to a person who would wait upon it, sit upon it, and in his own sweet time give his comments, which may not be total and holistic. Then it comes by post to this guy and he sits on it. Today, online, you have how many TFMs you have raised and how effectively has sourcing closed those TFMs for you. How many of them really contributed in terms of your knowledge of reducing costs further, getting down the part count further, right? So each department is empowered in their own areas to work in their functions, but leveraging the information that is available in a common system. So it does not say that all the departments has merged as one department. No, every department has its own work area that it needs to focus, but it needs information from other areas in order to do its work effectively, which is managed by PLM. I hope that answers your question.
Yeah, and just to add to that is, as you rightly said, every function has to be empowered to do that. But all of this, the most important point here is all of these functions have to be in a single platform. Otherwise, that can be achieved. And PLM basically is enabling that, like what Ravi is saying, whether it's manufacturing or service, all these functions are creating their own information, but in concurrent with engineering on a same platform. That is how this collaborative, thing can be established. Yeah. Okay, Kalyani, any other questions?
There are quite a lot of questions actually. So I'm going to try and broaden them. One gentleman wants to know, what are the challenges you faced during data migration and how did you manage to overcome them?
Typical question. Okay.
Okay, that's the most important aspect of it.
Yeah.
Probably that was our strength. That's the reason why we could make a turnaround which was so fast. Okay, to tell you the truth, we implemented PLM way down in 2006, and the next 10 years we remained stagnant on it. Then we took a call to re-implement PLM, and when we re-implemented, it means we just washed off the whole system and freshly re-implemented PLM, getting data from ERP freshly into PLM and doing it. There are specific parties available which does the migration. Okay, you can always get in touch with PTC, who will recommend you those people who can do this particular data migration properly. But what is important is that you need to have a very good insight in the functional aspect of the data. What needs to be taken? What is more relevant? What will help you for the future, right? Or do we get bogged down by the past data only? Because 100% correction of the past data is an impossibility. You will have some corners which will be left that, oh, this will not work. So you need to prioritize. When you prioritize, you need to focus on those particular areas and take them towards the next levels rather than getting bogged down by in the data set. Okay, but once you analyze, you spend a lot of time in planning. The strength that we had is we spend a lot of time in planning, pulling out reports, seeing this data, seeing that data, and finally figuring out how do we correct this data. And then when we implement it, we may still have problems. Okay, we should have the strength to overcome that particular problems and then go to the next phase of fail. That's the reason why I said in my presentation, the top management buy-in is very, very important, because you will have a phase when once you implement it, whether you back out, whether there's an acceptance or no acceptance, there would be these kinds of questions that will be raised. And we have to go through that when the the data is in question. I hope that answers the question.
Yeah. Okay, next question, Kalani.
So this is quite actually very practical and to the point. What is the duration as time for PLM as an average in the automobile industry? I believe this means I'm assuming it means how much time does it take to implement such a solution for specifically the automobile industry?
Yeah.
So in an automotive industry, when we're close to an automotive industry, being a diesel engine manufacturer, what I can say is on a PLM implementation, we did in two parallel phases. The first phase we did in version implementation only to handle our CAD data, because that is where we wanted to start first and clean out the CAD. And therefore, in 1.5 months to 2 months, we had a live CAD installation available on PLM, and our correction processes started. Parallelly, we started working on a fresh implementation of PLM, which took about a year to implement.
Yeah, but basically that year that includes the e-box stuff and
yes, it included
including the ERP
the complete data migration. At the end of it, we cut off access of ERP to any engineering personnel. Yeah. There was only one single source of truth, so that was PLM, and only through PLM the data will go to any other systems, including those.
Okay, thank you. Hello.
The next question, there's a lot of questions actually, I believe, coming out of IoT and how that can be and what is the relevance of IoT in PLM. But before that, if we can answer, is there any measuring tool for PLM in terms of how can you validate the PLM efficiency?
Okay.
So how do we measure the benefits of PLM?
That's right. That's a very good question. In fact, we have started managing PLM on PLM in Coel. Okay, it is not only for the products and the processes, it is also for managing our own PLM implementations in PLM, right? That means if I put in a particular process in place, how efficiently those processes are working, right? We have daily reports, we have weekly reports, we have quarterly reports and monthly reports, which goes to appropriate stakeholders, not as a control mechanism to put fear into people, no, but this gives an insight as to what changes do we make, what areas do we prioritize, what areas do we focus upon as a team. So if this kind of a guideline is provided to the team, the reports from PLM become extremely useful. This can also be added with some other business analytics tools and give much more insights to feed your strategy. Okay, having said that, how to measure the efficiency of PLM itself? As I said, you can manage PLM on PLM. It means any tickets that's raised through any other systems, okay, you can have the efficiency of closure of it, make small workflows for those things itself, but that would be a little bit transactional stuff, which I would not recommend to be a part to be maintained on PLM. There are better, smaller tools available for IT tracking as to when tickets were raised, when you have closed a particular issue, etc., etc. What PLM should be used for is how if you have done any modifications to your code, whether that code is being maintained into PLM, whether there's a revision mechanism for it, whether somebody has authorized a revision on it, when it was implemented, whether it was tested adequately as an user acceptance test, etc., can be maintained on PLM.
Yeah, but I think the intent was also to ask that suppose, for example, the engineering change management process is mapped inside a PLM. How do we ensure that that process is efficient, and how do we measure it in the PLM also?
Yeah, your bosses can answer the questions once the reports goes to them.
Yeah, so I think basically once you start managing all your process inside a PLM, you will understand the time taken and how many changes are happening, how the things are moving and all that. And as Ravi rightly said, once you take a report, you will be able to understand what's happening with those changes, whether it's a proto changes or production changes and things like that. So the whole idea is to basically get the more data from the process that are mapped in PLM to see what is happening and how we can really improve the things. Yeah. Okay, I think we can take maybe another 1 or 2 more questions.
Yeah, absolutely. Just about 1 or 2. So one of the questions will be on IoT. The first, before that, somebody, a gentleman has asked, how successfully can a company in the initial phase of growth of development, like let's say 2-3 years old, do data analytics. The main tools, stabilize process, ERP, the data integration are generally missing and lacking those years. How can one company go about this sort of a situation?
In fact, that is the best candidate to actually start the
Yes,
this particular technology implementation, because there is no legacy, there is no huge data. There is it's like more like a greenfield. So I think that is the best way. And in fact, as early as possible. In fact, 3 years also is already a late. Because if you can start PLM implementation, immediately, because you are growing, there is a lot of data coming up, and immediately, if that data can be properly managed into a system which can make you more efficient, effective as you grow, so that I think that is the best way to start. And of course, I'm going to cover that when I summarize, because there is a really way to start this PLM implementations by looking at certain priorities and business initiatives and things like that. So PTC can certainly help you to see that, how you can really start, and what are the initial steps to be taken, so which can create a foundation for you to for your company's growth also. Yeah. You want to add something?
Perfectly said, Neeru. That's a very right time that starting the PLM implementation so late, and as of now will enable the best technologies and the learnings that have come from other companies to you to implement at the first instant itself, so that you don't go through the cycle of realizing those things on your own and getting the pains of the PLM implementation, which was done a few years ago by many others.
And on those legacy data migrations and things like that. Yeah. Okay, maybe one more question, last question.
Yeah, so we'll end this question and answer with, sorry, what is your opinion about PLM on cloud or installed locally? How should a company go about strategically organizing this?
Yeah, I think we should not too much bother about whether PLM is on premise or on cloud. I think we should be more looking at like Ravi sir mentioned in the beginning, what should be the PLM business drivers and what processes we want to do, and what is the effective and efficiency that we want to bring out of PLM. Whether it's a cloud or on-premise is more of an IT strategy, and definitely there are certain advantages going to cloud, because you will reduce the total cost of ownership. You don't have to invest in hardware, the backups, the administrations, the upgrades, and all those things is again is anyway taken care by the people who will be hosting it. So you'll be only more focusing on what is the process and things like that. So I think there are customers who have gone for cloud. It is picking up. Definitely it is improving, and the future is definitely to go to the cloud. But again, I request that that is just more like an IT strategy, but more importance should be given to what do you expect out of PLM, what are the initiatives, and what processes will be mapped on that. Yeah. Okay. Yeah. Okay. So before we end up, I just want to summarize certain things. Like I also saw one of the question was, what is the latest technology trends and things like that are happening. So one of the thing you can see that, and as I also explained, and you also heard from the horse's mouth, Mr. Ravichandran himself, that PLM has not just remained into the engineering, but it has very comfortably extended to manufacturing and service, and even after the market. So PLM has spread across the organization, and we have already seen an example from Coil. We have more examples in India, whether it's a Royal Enfield or Tuffet Tractors or Godrej Interior. Like we have few more customers here in India who are using PLM, not just in engineering, but in manufacturing and also in service, where all this engineering, manufacturing, service are all related, integrated with each other, and they're concurrently collaborating on a PLM platform for the overall product development. So that's a trend, and we have already seen that a lot of customers are adopting to that. The second one is basically with the advent of IoT and with Industry 4.0 coming here, it's completely changing the way the products are designed, manufactured, and operated and serviced. And you have already seen my digital connected landscape slide in the beginning, how a PLM can enable that entire end-to-end product life cycle, which basically covers the industry, which is basically aligns with Industry 4.0. And PLM with IoT and augmented reality really makes that dream come true. Yeah. The third one is we are seeing a lot of new initiatives in the area of product development, whether it's a 3D printing, which is continuously enhancing and emerging with our latest CAD platforms. augmented reality, which is again by reusing the CAD data. Like Mr. Ravi mentioned, design for X. If we have to really make use of the field data back into my product development or PLM, then we have to start thinking about design for connectivity also, right? We think about design for manufacturability, design for service, design for assembly, similarly design for connectivity, where when you start doing a design in the CAD model, we start modeling the sensors which ultimately connected to the physical field and getting the data back. And of course data is the new oil. So there is a lot of data created across the product lifecycle, and there has to be a way to analyze and take some informed decisions based on data. And lastly, cloud, we just talked about it, transition to cloud strategy, and also providing a digital experience to the customer, right? Whether the end user or the operator or the service technician, when he actually works with the products, how do we really enhance his experience so that he can effectively and efficiently perform those tasks. So those are the trends, and which we have already seen with example from Coel, how these are getting actually implemented at the customer places. So lastly, if we do all this, that's what the continuous digital thread we can establish. And this is a small definition. You can see that on the digital thread, where basically unleashing the seamless flow of data across the value chain, okay, not just in engineering or manufacturing and service in isolation, but connecting the data across the value chain at every aspect of the product life cycle, going through all the stages. Okay, so that is what the digital thread, and with PLM, with IoT, with augmented reality, that entire digital thread from end to end can be established, which ultimately leading to a digital transformation. Okay, but how do we really start? That somebody also asked in the question answers, like a 3-year-old company, but how do we really get started? So PTC has a certain point of view, because if we have to do a digital transformation, we need to do a transformation in the engineering areas, in the manufacturing areas, as well as on the service areas. So PTC, with their 30 years of experience in the product development, we have come up with our own transformation journeys here. For example, if you just see the engineering journey, first we need to define the product with all the digital definition, then allow that digital data definition to be accessed by the downstream and upstream functions and things like that. So we have really certain outcomes. We can define the journey based on certain outcomes, whether it's a foundation phase, or it's an advanced phase, or an outperform phase. Similar approach we take in the manufacturing and service. We have to do some kind of a discovery session with each of you to define the information journeys and ultimately the digital roadmap for a particular company, and then embark on that particular roadmap to start the transformation journey. A few pointers. Establishing the PTC's leadership in IoT areas, whether it's a Forrester report or IDC, or as latest as Gartner's Magic Quadrant, where in most of the reports where PTC is established as the leader in IoT, and even in the Gartner Magic Quadrant, PTC is coming there in the visionary quadrant with respect to IoT. And again, with respect to PLM, the last year report from Forrester clearly putting PTC under leadership position, whether it is from product capabilities point of view, or our overall strategy and vision of integrating ultimately with IoT and AR to make that physical digital convergence, right? So ultimately, as a next step, feel free to contact PTC guys, where we can discuss these transformation journeys and craft a specific roadmap for your kind of a company and your initiatives to do that digital transformation, right? So that is the last slide, and I think we have absolutely come to the end of this presentation. Thank you very much. I think unfortunately we were not able to answer all the questions, but Kalyani, if there is any way to send us those questionnaires and with the contact persons and their email IDs, probably we can make an attempt to write back to them and connect them and answer those questions. So that's all from our side. It's over to you, Kalyani.
Bye-bye. Thank you.
Yeah. Thank you. Just again, very thanks a lot to Mr. Ravichandran for actually helping us and guiding us. And of course, a very, very big thank you to all the attendees. I hope it was very informative for you, and we are going to host another webinar, so we hope to see you next time as well. Enjoy your evening and the weekend. Thank you.
Thank you. Have a good day. Bye.